Okay, in this video we'll look at while loops and do while loops again. Now sometimes we know beforehand like exactly how many iterations we want, so how many times we want that loop to repeat. Sometimes we don't know that. Sometimes we want the user to specify or enter some value, a unique value that will stop and break out of that loop. And so we look at just few examples of ways of how we can control loops in this video. Sometimes we know in advance or like beforehand how many times we want the loop to repeat, and that is where counter-driven loops comes into play. So the number of iterations or repetitions is determined by a variable called the counter variable, and basically this is also the loop control variable, and the counter variable keeps track of how many times the loop will repeat or is executed. Okay. Now the counter variable is initialized before the loop and is incremented or decremented in some situations as well in the body of the loop. So it's not always incremented, sometimes it's decremented. Now this is used when you know the exact number of iterations in advance, as I mentioned, and so the loop is going to end when a predetermined value for the counter variable is reached. Let's say we want the loop to repeat 3 times. Okay, then we set our variables according to that. So the basic stuff that we talked about before still applies, and you can remember this as the ITC principle. So initialize, test, and change, the loop control variables, that is, okay, and that it applies to both the while and the do while loop. Now the order is not always the same, of course. You test last when it comes to the do while loop. You initialize and then you change it in the body of the loop, and then you'll go and test it, but still the same principle applies. Okay, so here's a quick example in Visual Studio. I have the counter variable, which I'll set in this case to 0, because down here I want to print it out again. I have to always remember that this final increment will also count, so just keep that in mind. So in this case, while counter is less than 5, go and print that counter out. Again, just a simple quick example here, and then increment that counter. We'll just run that. You can see 0, 1, 2, 3, 4. And then finally down here I print that out. Now the reason why 5 does not print out, where we have 0, 1, 2, 3, 4, we don't have 5 because it's going to print out 4. So 0, 1, 2, 3, 4. And then it's going to increment that. Okay, then it's going to be 5. Then it'll go back up here and see that 5 is not less than 5. Okay. And then it's going to exit that loop. So that loop will not repeat again. But the counter variable now has been incremented, and that will stay that way. And then I have this example that I showed you previously. I'll just build and run this. The game starts in 5, 4, 3, 2, 1, play. Okay, so in this case we have this iterator here, which is basically the counter. But in this case we are decrementing, alright, so we're not incrementing. I'm not concerned in this case with printing out like how many times this thing has repeated, so 1, 2, 3, 4, 5 as we have in the previous video. So it's a bit of a different counter, but in using the counter we can specify exactly how many times we want the loop to repeat. You might have to kind of do that in the back of your head, a bit of calculation. Okay, let's talk about accumulation next. Now loops are often used to accumulate the sum or product of values. So this could be integers or floats, and we can even add strings together, for example. Now we store the result of the sum or product expression into a variable called the accumulator. The accumulator is initialized to 0 before the loop for the accumulation of a sum. So if you want to add a bunch of integers together, for example, then you set the accumulator to 0, of course. Then the accumulator is initialized to 1 before the loop for the accumulation of a product. In other words, if you want to multiply a bunch of integers together, for example, then you will initialize that accumulator to 1 again instead of 0. Because if you multiply 0 with something, then you get 0, as we'll see in the next example. Okay, in this example, I'm still using the counter. Okay, let's say I know that I want to add 5 values together. Now, in some cases, you don't know like beforehand how many values the user will want to add together. Now we'll take a look at that in the next couple of examples, okay, when we talk about Sentinel driven loops. But in this case, let's say we know beforehand that we want to add 5 values together. Okay, so that's why I'm using this counter. So this will loop 5 times. Then I do an input. So I have another variable here, temp, that initialized to 0. And I just keep adding values to that. Now the accumulator, you can see here, is also initialized to 0. And I'll just add whatever I input here into that variable. I'll add that to the accumulator each time. Increment the counter and, keep going. Down here, I just print out the counter and the accumulator, just so that we don't get kind of a blank console that pops up when we run this initially. I just print out this enter 5 values to add together or to sum or, whatever you want to write here. Okay, so Control F5 to run this. You can see it says enter 5 values to add together. You can see the counter is 5, the accumulator is 25. Run this again. So you see we get 30 from that, so it seems to work fine. Alright, so just a basic example. Again, you have the accumulator, so we keep adding whatever the user enters. Okay, we keep adding that. And because it is set initially to 0, it won't make a difference. Because if you add 0 to something, to x, then you'll get x out of that anyway. Okay, but what if you want to do multiplication? So if you want to do the product of some series of inputs. So I'll change that to multiply. Now we'll get a problem. So I'll just run this here. And we'll do 5 again. And you'll see the accumulator is 0. That's because we are multiplying initially by 0. Accumulator is set initially to 0. So I'll set that to 1. And you can see that will add that up for us. Okay, so just a quick example of the accumulator. Okay, so as I mentioned previously, sometimes we just don't know how many values the user would like to enter. And so this is where Sentinel-driven loops come in. Now these are loops that are often used to input a sequence of values without knowing in advance how many values the user will enter, or in other words, how many times the user would like that loop to repeat. Now we can ask the user to enter a value, some unique value to end the loop, like a secret code or something like that, right, to stop that loop. Okay, so how does this work? Well, the user enters all values or numbers, typically pressing enter or return after each entry, right? You enter 5 or something, then you press enter. And you keep doing that until you are done. Okay, I've entered all of my values. Now I want to stop that loop and see the results of whatever calculation is going on. Okay, so once all of the values have been entered, the user enters the unique value, of course, called the Sentinel, to end that loop. Alright, so let's look at an example. So in this example, I'm using the accumulator again, but in this instance, instead of using a counter, I'm using the Sentinel. So I'm doing console input temp, and I'm adding that to the accumulator. So let's say again we have a program where the user enters a bunch of numbers to add together. Of course, you can do product or whatever else you want. And let's say the Sentinel, or the keyword in this case, is 0. Okay, so I set this as a variable to 0, and I've added that here. Now, of course, you can just put the literal right here. So 0 for the Sentinel. I'm just writing it out like this to, make it clear on what's going on. What is the Sentinel exactly, and all that kind of stuff for your notes and revision. And, when you come back to this, you can see, oh yeah, that's where the Sentinel goes and that kind of stuff. Okay, so before I continue here, what I'd like you to do is, I'd like you as an exercise to go and compare this program to the previous program where we also used, now in this case I'm doing addition, but other than that, to go through line by line basically and compare this to the program again where we add the numbers. Now I changed this here because again we are adding a 0 as the Sentinel and the variable, but go through here and look at the ordering and so on, and try and think about like why we do things. See, it's not that difficult, but when you go through and you write programs, you have to kind of debug and you have to think about the order of your statements. So pause the video and go and take a look again, compare the statements, the order of the statements. Alright, so I'm just going to continue here. I'm going to assume that you've done that and that you understand what's going on. If you don't, that's fine. We'll just continue and try and explain what's going on here. Control F5 to run this. It says enter numbers to add together. I'll just add a bunch of numbers and now I'm done. Okay, so I want to stop the loop. So I'll do 0 because that's the secret code here, the Sentinel. Alright, so 0 and it gives us the result. Accumulator is 30. You can see that prints out down here just like before. In this case, we are not printing out the counter. We don't have one, so we are just printing out the accumulator. Okay, so what's going on here? So I'm printing the stuff out. Then I'm doing an input. Now I'm doing that input before we reach the loop, because if I don't want the loop to execute, even once, then I can just enter 0. So if I enter 0, we'll just skip the loop. Also, if I were to comment the stuff out, and I'll build and run that, you can see it's just simply going to run the program and we don't get a chance to enter anything. That's because temp and sentinel is both 0, right? So this is going to evaluate to false here. It's not equal to, it's not equal to. So while these two things are not equal to, we want to keep executing the loop. Alright, so I'll have to do that input before we get to the loop. So if I enter something other than 0, then the loop will enter. And of course we want to add that temporary variable, whatever we entered into that, to store it into that, we want to add to the accumulator before we do another input. Otherwise, that temporary variable is going to change and we're going to enter that. Okay, so it might override what we entered the first time. So the order of these statements are important here. Finally, for this video, I'd like to talk about situation-driven loops. So when a counter or sentinel variable does not determine how many times the loop will repeat. So the loop ends under specific conditions, as opposed to having a predetermined amount of repetitions, as you do with a counter, or when you have the user enter 0 or something like that to break out of a loop or to stop the loop once they are done entering a sequence of values. So these loops will also contain one or more loop control variables, but those do not act as counter variables. And you also have to remember the ITC principle, so initialize, test, and change the loop control variable in your program. So let's look at a quick example in Visual Studio. And so basically the goal here is to write a program that determines how long it takes in months. So down here you can see in so many months, the player count will exceed the server limit. Okay, you can see the server limit here is a constant, set to 1000. Just a silly example. So I also have a variable here to keep track of the amount of months, and that will increment each time the loop runs. So we start by entering the amount of players on the server currently. So you enter that, and then in the while loop, so while the amount of players is less than the server limit, you increment the month count. Let's assume that it is given, okay, for this example, that the amount of players increases by 15% each month. And so because of that, of course, what we'll do is we'll multiply by 1.15 each time this loop executes. Okay, and down here I just print that out again. So let's just see what happens here. I'll enter something like 5. So enter current amount of players on server, 5. And then that will increase each month. And then in 38 months, the player count will exceed 1000. So it's a silly example, but basically what happens is we don't have a sentinel here, and we also don't really have a counter, mainly because the user can enter, anything. They can enter 50, so 50, right, or whatever they want. So basically, we don't have a counter because it's not going to loop only 5 times, for example. We cannot determine beforehand how many players the user will enter, so we cannot determine how many times this while loop will run. Similarly, we also do not stop the while loop after the user enters a specific number. Okay, it's going to keep looping until a specific situation has reached or a specific condition has been met. In this case, when this here is false. So when the number of players here exceed the server limit. Okay, then we'll exit out of that while loop. Alright, so quick example on that. Now we do have a few more things to cover in the next video on input validation, for example, and then we'll look at the difference between the while and the do while loop again. Alright, so I'll see you in the next video.